Hello, student. Let us discuss today the topic that is called Ampere's circuital, or sometime it is called Ampere circuit law. To discuss this Ampere circuit law, first let us consider an infinite carrying conductor which carries the current I. You know that when current carrying conductors carrying the current I, then it will produce magnetic lines of force. Let us consider a small element dl on this magnetic line at a distance r. करंट पास किया, लाइंस प्रोड्यूस हुई, उसकी एक ही लाइन पे एक स्मॉल एलिमेंट कट कर लिया जिसकी लेंथ थी dl, and this dl is at a distance r. Let us find b vector dot this dl vector. Yeah, now you know that if you apply right hand thumb rule, then magnetic field will be in this side, and the direction of the angle between dl and b, you can see the angle is 0. So if I solve, I get b dl cos 0. This is a sign of integration. This line, this is called closed path. This closed path. Okay, take b outside, inside you get dl cos 0 is 1. Now question is, what is b? B is the magnetic field produced by this current carrying conductor at distance r. And you know that in previous article, magnetic field due to infinite current carrying conductor is given by mu naught I upon 2 pi r. If I put in above equation, it becomes b vector dot dl is equal to, yes, it will be mu naught I upon 2 pi r integration then dl. The question is, what was dl? dl is this small length, but if I integrate, I get this total length, and this total length is nothing but equal to circumference of the circle. So circumference of the circle is given by this multiplied by 2 pi r. 2 pi 2 pi cancel out, so this comes out to be, it means after solving I get that b vector dot dl is equal to mu naught times the current flowing threading in that circuit. This law is called Ampere circuit law. As Gauss's law states that the surface integral of Gauss's law, the surface integral of electric field is equal to net charge divided by epsilon. In the similar way, Ampere circuit law states that the line integral of magnetic field around a closed path is equal to mu naught into, it is not equal to 0. It means magnetic force is not a conservative force. You know that the work done in for the conservative force is equal to 0. So that is another concept. So you have to remember this. Now there are two applications of Ampere circuit law. First application, to find the magnetic field inside a I think in 10th class it is clear to you what is solenoid. Solenoid एक बच्चे क्या है, cylindrical tube है. On this cylindrical tube there are number of wires like this. The condition is the length of this is more than that of its diameter. इसकी लेंथ अपने डायमीटर से हमेशा क्या होगी, ज़्यादा. Now we have to find the magnetic field inside. ये red line आपको नजर आ रही होगी बच्चे. We have to find the magnetic field inside this solenoids, and we have to find this with the help of which law? Ampere. Since it is application Ampere circuit law, so we have to find using Ampere circuit law. So let us start. So I will consider a solenoid. थोड़ा सा बड़ा बना लेता हूँ इसको. So I consider a solenoid having number of turns. So I write let n be the number of turns per unit length. So it will be n into L, equation number 1. To apply the Ampere circuit law, I will consider a closed loop. Now sometime question which asked, sir, what is this closed loop means? You know that when you apply the Gauss law, then you consider a Gaussian surface. In the similar way, when I apply Ampere circular law, I have to consider the closed loop. That loop is called Amperian loop. That is, closed loop is called Amperian loop. Let I be the current in this solenoid. Now you can see this A, this is B, this one is C, and this one is D. So I will find my this formula of check करना बच्चे B vector dot dl in closed path. What is the name of closed path? A B C D. The name of that close you can see A B C D. This can be break into four parts. First I start with AB, B vector dot dl plus then next part is BC, B vector dot dl plus next part is yes बोलो AB BC, next is CD. Very good. CD बोलो next बच्चे CD के बाद next is DA, B vector dot DA. इसको separate. So we split this closed path into four parts: first, second, third, and fourth. So magnetic field inside this solenoid. Magnetic field is inside this solenoid. It is not outside. It means if it is inside the solenoid, the contribution of CD will be zero. I can neglect CD. Why? Because it is outside, and outside magnetic field is zero. What's about this check बच्चे? This is magnetic field this side, this is length. This angle will be 90 degree. Similarly, magnetic field this side, this angle is also 90 degree. It means the contribution of BC and AD is also zero because theta is 90 and you know that cos 90 is equal to 0. So you left with only which loop बचे? A B C D जो आ रहा था क्लोज लूप A B C D. After solving I get it comes out to be AB B D L cos 0. Why? Because DL and magnetic field in the same direction. Cos 0 is 1, B outside, it is DL. Let us suppose its length is L. So it is B into L, equation number 2. One we have written in this one, equation number 2. But what will be according to Ampere's circular law? अभी ऊपर प्रूफ किया था, उसने कहा था कि अगर किसी भी लूप में आप देखते हो तो वो होगा P डॉट म्यू नॉट आई. आई कौन सा? आई इज द करंट इन लूप, इन दैट लूप. I is the current in that loop. So it means first I will find the number of turns in that loop. So multiply by number of turns. Why? Because I suppose that I be the current that is entering, but I have to calculate the current in this loop. इसमें कितना करंट है तो मल्टीप्लाई जितनी इसमें टर्न्स है, क्योंकि उस टर्न में से होकर करंट जा रहा है. इसमें कितनी टर्न्स है? n into L, because we know that n is the number of turns per unit length. To calculate the number of turns in this, I will multiply with its length. So this is equation number 3. If you compare 2 and 3, both represent B dot dl, both represent B dot dl. So I get B dot L equal to n mu naught I into L. LL बच्चे कट गए. What will be magnetic field? Check करना बच्चे. N mu naught I. This is the magnetic field. This is the magnetic field. This is the magnetic field. And once again, magnetic field is, what is N? What was N? N was number of turns per unit length, mu naught, and I is the current in the solenoid. N is the number of turns per unit length and I is the current in the solenoid. If I plot the graph to find this variation, you will find this is center of the solenoid. So magnetic field will decrease like this outside the solenoid. This is the variation of magnetic field, and inside it is this, but as you move away, this is up to its length. ये लेंथ से बाहर होगा, दूर जाते जाओगे मैग्नेटिक फील्ड कम होती जाएगी. अंदर जो मैग्नीट्यूड है सेम है उसका. नेक्स्ट, दिस वाज द मैग्नेटिक फील्ड ड्यू टू ए सोलेनॉइड. नेक्स्ट क्वेश्चन इज फाइंड द मैग्नेटिक फील्ड ड्यू टू TOROID, दैट इज कॉल्ड टॉरॉइड. सोलेनॉइड को पकड़ के एक सर्कल में बना दो. join कर दो. If you join this solenoid like this, now this is a solenoid. अब it consists of number of turns. यहाँ से करंट एंटर करेगा, ऐसे घूम के जाएगा. सोलोनाइड के अंदर भी मैग्नेटिक फील्ड इज ओनली इनसाइड, नॉट आउटसाइड. याद रखना बच्चे, इसके करंट यहाँ एंटर कर गया, सो मैग्नेटिक फील्ड इनसाइड, नॉट दी आउटसाइड. सो इफ आई कंसिडर this I want to find the magnetic field 2 point. One is A point, another is B point. That is, there are two cases. One is inside, another is outside. Now current is only in this loop. Okay, if I taking this, I consider a Amperian loop. You can see this is Amperian loop. So case 1, magnetic field at A. So draw Amperian loop. So that A lies on its axis. Now you can see in this case what will be B vector dot dl equal to mu naught I. What is current? There is no current in this loop, so 0. So magnetic field inside this loop will be 0. Magnetic field in this loop will be 0. चलिए आगे बच्चे. So now I want to find at this point P, this, and I suppose this distance is average distance is R. Again Amperian loop you draw. So case 2, at point B बोल दिया, चलो B मैग्नेटिक फील्ड भी होता है B. So again you will take B dot dl. It will be mu naught times the current where, so again in this loop. So but I is the current that is anti, so multiply by number of टर्न्स. पीछे भी क्या था इसमें, इसमें फिर से यूँ करके व्हाट इज एन नंबर ऑफ टर्न्स पर यूनिट लेंथ. एन विल बी एन इंटू लेंथ, सिंस इट इज ए सर्कल, सो लेंथ विल बी सर्कमफ्रेंस. सो पुट दिस वैल्यू, व्हाट विल बी बी वेक्टर डॉट डी एल बच्चे, देन इट विल बी म्यू नॉट आई, चेक करना, एन इंटू 2 पाई आर, इक्वेशन नंबर 3. बट if you solve and get the value of B vector dot dl, चेक करना बेटा, यहाँ पे एक एलिमेंट लिया स्मॉल, dl उसकी लेंथ है, तो उसमें अगर आप सॉल्व करोगे यू गेट बी डी एल cos 0. cos 0 is 1. again it is, since it is a closed path, so it will be again circumference. and if you compare बेटे देखो ये दोनों सेम चीज़ों को रिप्रेजेंट कर रही है. सो b इंटू 2 पाई आर इज इक्वल टू म्यू नॉट आई n into 2 pi r. So 2 pi r क्या हो जाएंगे बच्चे, कैंसिल. सो आंसर विल बी n mu naught into I. The result is the same as that of the solenoid. The only difference, solenoid is in the straight but the centroid in the. So when you solve the numerical, sometime in the numerical it will be given to you that this is a toroid, its inner radius is r1, its outer radius is r2. Solve and get the value of this magnetic field. In that case, when you find this n was what? It was a number of per unit length. To find the length, you will take the average of these two radius. Average of these two radius. So this is the last topic, the first part of magnetic effect of current. And this year 2020, the question was, there was a solenoid was given to you. Solenoid is given to you. You have to find the magnetic field at point P, which is some distance, find distance from the center of the solenoid. So try this question. If you're not able to solve, we will solve in the chapter magnetism a little bit. If you want to try it, thank you very much.